Let's go to number 10. It is given that f of x equals 3x to the fourth power plus ax to the third power plus bx squared minus 7x minus 4, where a and b are positive integers. Given that x squared minus 1 is a factor of f of x, find the value of a and the value of b. Since x squared minus 1 is a factor, for x squared minus 1, we can also factor x plus 1, x minus 1, which means x plus 1 and x minus 1 are also the factor of f of x. We will set up this equals 0 to figure out the roots. x1 equals -1, x2 equals 1. Since x1 and x2 are the roots of f of x, we know f of -1 equals 0 and f of 1 equals 0. We will use these two equations to figure out a and b. F of -1 equals 3 times -1 to the fourth power plus a times -1 to the third power plus b -1 squared minus 7 times -1 minus 4. -1 to the fourth power is a positive 1. -1 to the third power is -1. -1 squared is a positive 1. So we get 3 minus a plus b plus 7 minus 4 equals 0. Combine like terms. So -a plus b plus 6 equals 0. We will get -a plus b equals -6. For f of 1 equals 3 times 1 to the fourth power plus a times 1 to the third power plus b times 1 squared minus 7 times 1 minus 4 equals, this is a 3 plus a plus b minus 7 minus 4. We set up this equals 0. A plus b combine like terms minus 8 equals 0. So we get a plus b equals 8. We need to solve this system of equations. -a plus b equals -6. A plus b equals 8. Adding 2b equals 2. So b equals 1. For a equals 8 minus 1 equals 7. So we have a equals 7, b equals 1. The solution to 10a is a equals 7, b equals 1. Now let's go to b. Factorize f of x into a product of linear factors. Since we already get the value a equals 7, b equals 1, we can write down f of x equals 3x to the fourth power plus 7x to the third power plus x squared minus 7x minus 4. When we are looking for all the zeros or the product of linear factors of a polynomial function, we will use synthetic division. We already know the two roots of f of x, x1 equals 1 and x2 equals -1. We will use these two rules to do the synthetic division. Let's do 1 first. No missing power. So 3, 7, 1, -7, -4. 3 bring down, 1 times 3 is 3, adding 10. 1 times 10 is 10, adding 11. 1 times 11, 11, 4. 1 times 4 is 4. So we get 0 here. Keep doing the synthetic division by using -1 as a root. Drop down 3. 3 times -1, -3, adding 7. -1 times 7, -7, adding 4. 4 times -1, -4. 0. We know this is x to the fourth power, so x third power, x squared plus 7x plus 4. So we get the f of x equals x plus 1, x minus 1, then times 3x squared plus 7x plus 4. We will do the ninja x for 3x squared plus 7x plus 4. That is 12, 7 over 3 over 3, 3, 4. Reduce 1, 1. Put the x bottom up. We will get x plus 1, x minus 1, x plus 1 again, 3x plus 4. This will be the solution to 10b. We can also use graphing calculator to figure out this product of linear factors. First of all, let's analyze this graph. Suppose this is A, this is B. We know A and B are the roots of this f of x. When the graph bounces back at A, the graph has a factor of x minus A to the eventh power. When the graph crosses x-axis at B, which means the function has a factor of x minus b to the odd power. We know this is 1. Here is a -1. The graph bounces back at x equals -1. Let's figure out this 0. Second trace, 0. This is -2. So let's put the -2 as left bound. Then move the arrow, enter, enter. We know this x is a rational number, so we quit. Then press X, enter. Math, enter, enter, to change this root into fraction. Let's label the roots. +1, -1, and -4/3. We know the degree of this f of x is 4. So when the graph bounces back at x equals -1, we will have factor x plus 1 squared. This one, x minus 1. For -4/3, we will change into factor x plus 4/3. Then move this 3 to the front of x. We will get 3x plus 4. Now we get the product of linear factors of f of x equals x minus 1, x plus 1 squared, 3x plus 4. Say, using your graph state, the range of value of C for which f of x equals C has exactly 2 distinct real roots. Two distinct real roots means y equals c, this horizontal line, will cross f of x twice. We know the graph of f of x like this. When y equals c above x-axis, there will be two intersections, or this c is between these two values. There will be two intersections. So we need to figure out this local minimum point and this local minimum point from graphing calculator. Change the window. For y minimum value, let's change into negative 50. 50. Scale is a 5. Graph. 50 is too big, so let's change window again. Let's do negative 10. 10. 1. Let's figure out this minimum point. Second trace. 3. Left bound. Enter. Then move the arrow to the right bound. Enter. Enter. We know the minimum value is negative 6.20. We still need to change the window to figure out minimum value of this part. Negative 0.1 and 0.1. Graph. Second trace. Go to 3. Left bound, negative 2. Enter. Right bound, move. Enter. Enter. So minimum value is negative 0.0366. This minimum value is negative 6.20. This minimum value is negative 0.0366. So when c greater than 0 or c greater than negative 6.20 less than negative 0.0366, there are exactly two distinct real roots for f of x equals c.